Welcome back, everybody. In this video, we're going to take a look at how to solve equations that may not look linear on face value but turn out to be. But in order to do that, you need to understand how to solve equations that look linear, so go ahead and watch the last video in this series if you haven't already. Let's get started. Let's take a look at this first example. Now, I claim that this is actually a linear function, but there are fractions, so what gives? Well, let's try and clear those fractions first in the name of simplifying the problem. I see I've got a 4 here in my denominator for the left-hand fraction, and I know that I can do the same operation to both sides of an equation without changing its solution set. So one thing I could do is I could multiply both sides of this equation by 4 without changing its solution set. Now, I do have to multiply the entire left-hand side by 4, not just one of the terms. So those parentheses I drew are important. For the first term, the 4's cancel out, and I'm left with just x plus 2. In the second term, though, I have nothing to cancel out. So that 4 is going to go into the numerator. And on the right-hand side, I'm left with 8. I've still got another fraction, though. So how do I clear it? I multiply by its denominator on both sides. In my first term, remember, I have to distribute that 3 to all of the terms. I'm going to get 3x plus 6 minus, and now that 3 is going to cancel with the denominator in my fraction and leave me over with just 4 times x minus 1 equals 24. Now this should look like a linear equation to you. Go ahead and pause the video here to see if you can solve this one on your own. I found the answer to be x equals negative 14. If you would like, you can pause the video here to review my work. Ready for the hint? If y is equal to z, then it must be that this expression for y is equal to this expression for z. In other words, 2 over x plus 4 plus 3 over x minus 4 has to equal 44 over x squared minus 16. See if you can take it from here now that it looks more like the problems we've been solving in this video. The final answer is x equals 8. The very first step I did was I fully factored the denominator on the right-hand side into x plus 4 times x minus 4. And in order to clear the fractions, I multiplied both sides by its denominator first, but that actually ends up taking care of all of them, because in this term, I'm going to cancel a factor of x plus 4 top and bottom, and I'm left over with just x minus 4. And in the right-hand side, I'm going to cancel a factor of x minus 4 top and bottom, and I'll be left over with just x plus 4. Now, I have a much easier problem to solve. I distributed my 2 and 3 to get here, and combined like terms to get here. Then I subtracted 4 from both sides to get here, and divided by 5 on both sides to get here. In this video, we took a look at how to solve equations that don't quite look like linear equations on face value. And the trick I'm hoping you take away from this video is to always fully factor and clear fractions before you decide what strategy to use. Catch y'all on the next one.